Hi friends, today on 1 Minute Math, we're looking at limits. This is a calculus concept. You might be asked to find a limit, calculate a limit, or compute a limit, and today we're just doing the 1 minute overview of how do you compute a limit. And if you're asked to find a limit, the first thing you want to try and do is substitute the value in, if it's given to you algebraically. If that doesn't work, you can simplify with some factoring, do some algebra, and then try substitution again. Or if the problem is given to you graphically, or none of those other things have worked, we could use graphs or tables of values to approximate. We'll see an example of all three of those things. Now, the further you go in calculus, you might also want to consider that you're being asked to recognize the limit definition of the derivative or use L'Hopital's rule. We're not going to address those in this video, but I wanted to make you aware that those are other things that might come up later in calculus. Okay, so let's take this first one. We're going to go back to that graph page in a second, I promise. We're going to take this first one, and I'm asked to evaluate this limit. The first thing I'm going to try is to just literally plug this x value in for everywhere I see x. 3 times 0.5 squared times 2 times 0.5 minus 1. And I notice that this will give me a value. 2 times 0.5 minus 1 is 0, so this whole expression equals 0, and that's the answer. Now, if I try this next thing, I'm just going to plug these in. 2 squared minus 3 times 2 plus 2 equals 0. 2 squared minus 4 equals 0. This gives me the very bad quotient of 0 over 0, which I'm not even going to write down. If I write that on my page, it might burst into flames. We don't write 0 over 0. We definitely don't write equals 0 over 0. But I'm noticing that I have 0 on the top, 0 on the bottom. Very scary. So that next thing, if I go back here, simplify with some factoring and then try plugging it in. So if I simplify this top, and notice I'm going to write equals limit. I'm not letting go of the limit until I actually substitute a value in and get a numeric answer. I factor here, x minus 2, x minus 1. The bottom is x minus 2 times x plus 2, which, oh, look at that. I can cancel out one of these factors. I'm only allowed to cancel that out because x is not equaling 2. When we're talking about a limit, we're talking about all of the values near 2, but not equal to 2 for an x value. So now I'm allowed to rewrite this as simply x minus 1 over x plus 2. And now when I plug in my values, 2 minus 1 is 1, 2 plus 2 is 4, I get an answer of 1/4. All right, that's how we do the simplification and then substitution. The last thing we want to look at here today would be these guys. Let's say I'm asked right here for the limit as x goes to -1 of f of x. So I think x is going to -1, and I just project that up onto my picture and ask where are the y values approaching. And in this case, those y values are approaching 4, and that would be my answer of 4. If I'm asked this bottom one, the limit as x goes to 4, I can see those y values are approaching 2. They don't ever actually achieve 2, but that's still my answer. A couple other fun things to point out here. Like if I'm asked for the limit as x goes to -4, and I imagine the x value is near -4, one branch is pointing towards a y value of 3, the other branch is pointing towards the y value of -2. Those don't agree, and I write does not exist. You might be familiar with one-sided limits. If I'm looking here at this one, coming to 2 from the left. Okay, that's what that little minus in the superscript means. Coming to 2 from the left, those values approach -1. Coming to 2 from the right, those y values approach 5. All right, I hope you found that helpful. Thanks for watching. If you want the full explanation of this whole topic, please look for the full explanation link in the comments. Thanks.